second recording I'm doing on Tuesday, July 31st, 2012. This is recording number 7? 7? I think 7. We're going to go with 7. It's a lucky number. That I'm of the series, but we're doing it right after the re-record of lecture number 2. So if you've been watching nonstop, we've just talked about Boolean logic and loops, which is going to be a bit of a switch because that's a real basic topic, and now we're going to pull into some more advanced stuff. We're going to do functions part 2. Functions, yeah, we're just going to do a little bit more of a look at how you use functions, or kind of what you use them for, not really how you use them. We're talking about how we used them last time. We're going to kind of see a more practical examples from my old code. Let's see. Up there, CSCI 1730, the C++ class at my school. And this is a calculator. This is just a real simple for function plus a little calculator that you could go buy for, I don't know, $10 in any store anywhere. Or, if I get rid of you for half a second. Didn't mean to do that. Or not even as complicated as this thing. It's not even as complicated as this one, but it's a calculator. You know, everyone starts with one. 30 years ago, they were a big thing. It's also a good way for me to show C, which is why I picked this, or C++ specifically, though I believe this will actually cross-compile as both. I don't know that for sure, but anyway. So yeah. This is a calculator. I thought it'd be a good kind of introduction to seeing what you do with functions, because it's very function-oriented, which isn't a real term. Don't go say that to people. Function-oriented. That sounds like you think you know what object-oriented is, and you don't, and you call it function-oriented. Don't do that. But anyway, so here's the main. You'll remember somewhere along the way I've mentioned that main is always your entry point into a program. I believe that I actually said that in functions part 1. Excuse me. So your entry point is going to be here. A little bit about C, just to kind of, so you don't seem completely lost, because this does look very different than Java. I know it does. You have these prototypes up here which just say, hey, these functions exist. You have to let the compiler know that at the beginning. And then I have some includes up here, which is the same thing as a Java import. And then using a namespace, which means I don't have to include the long library listing of where things are. Just some kind of, this is all clerical stuff. It's not really the interesting bit, but I thought I'd mention it since we're looking at C for, I think, the first time. I don't think I've pulled it out before. So here we're going to have an input. Yeah, here we have an input that the user is going to give you for what they want to do. And it'll print out, welcome to command calculator. I don't know why we named it that. Probably because my professor is less creative than I am, and I'm pretty darn uncreative when it comes to my names. But here's an interesting bit. While true, I mentioned this about 10 minutes ago, so I just thought I'd bring it up real briefly. This is actually used somewhere. I didn't just make that up. You actually do this. And here's an example: is when you want a calculator to run indefinitely. So then you have print menu here. I won't go through the whole thing like this, but I just want to kind of ease us into it since we're probably all still a little new with functions. Print menu is a function, and in this case it's going to drop us down here, which is going to do cout and then the string insertion operator, which you don't need to know really. It's just, this is how you do system out println in C. System out print lines in Java, this is the C equivalent of it prints what's in these quotation marks right here. It just prints a little menu that says, you know, what do you want to do? And gives them a number. And then the user inputs a number. You'll notice that there were no requirements to validate user input here. So they could put in, you know, cheese, and it would just come down here and go invalid input. But it's not going to, like, only limit you to the proper inputs. But here we have a switch statement with cases. I haven't gone over switches. I don't terribly like switches because they're just a way to rewrite if blocks. But if you're interested in what they are, Go Google it. They're pretty simple. But we're going to do our print menu here, and then we have a read operation over here, which is just going to take in an operand. It's going to say, hey, give me something, and then it's going to put it into this value and return it, and then that's going to be assigned to this input right here. And this is a great first example of why functions are awesome, because it allows us to isolate out the assignment and the user interaction. Because here we could just say, here, give me this, and then assign it to that value. But what if we want to do the operation more than once? Let's say we need 2 user inputs. Then, here, we'll get there in a second on the 2 part, but let's just say we wanted to do 2 different functions before we gave them the menu again. Well, then we'd have to use that same block of code twice, but here we can just call the function twice, and it'll say, please enter whatever. Sorry, just looking at my old code. It's actually this function. But the distinction is minimal between the two. You'll notice the only difference is the fact that this actually says, please enter something. In this case, operand 2. So inside each one of these, you'll notice that we have a function, a comma, another function, and all that wrapped inside a third function. What all these are doing are saying, read in an operand with this name. In this case, we just named it operand 2 and operand 1. We just named them that, and then it says, please enter operand 2, and then it reads it in and returns it out. So that way, we ask for user input here, we ask for user input here, and then we pass them both into the myAdd function, which you'll notice is not in this file. It's nowhere to be found. Instead, it's included from operations.h over here, which is a header file, and we're not going to go into how headers work, even though they're not terribly complicated. It's a header file, which then includes this file. And you'll notice this file just is a library of functions. It's just double myAdd, double mySubtract, double myMultiply, blah, 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 blah. The coolest one is double myFibonacci down here. Which I think they actually told me to do it recursively, and I just said, no, that's an easy way to break things, and did it iteratively instead. But recursion versus iteration is another topic. We'll probably be there, though, in like a week or 2? Oh, I don't know that far ahead, but I'd say in like 2 weeks I might cover recursion versus iteration. Anyway, so instead of having to run this whole piece of code and then save it in this operand and then save 2 of them and then pass those into myAdd, instead we can just chain them together inside the inputs of myAdd, and then this will return a double that has the correct value. And all of these really do the same thing. Division, sine, cosine. We kind of cheat here because it's here my sine. I mean, it's kind of silly. But it was a first project in school, so it was designed to be kind of silly. I'm now realizing that recursion is a really cool way to show off why functions are really awesome, but we can't go there yet just because it's a different programming paradigm that I don't want to try to overload you with right now. But this is a cool little function. Can I just say Fibonacci is cool? How this just shuffles and adds them together. The Fibonacci sequence, if you don't know what it is was created by the guy Fibonacci. But it's a sequence of numbers that that will approximate the golden ratio as they go out to infinitely large values. And they're found by adding the last 2 numbers in the sequence together. So for example, you start with 1 and 1, or you could start with 0 and 1 actually. So 0 and 1, you add them together and you get 1. And then 1 and 1, you add them together and get 2. And then 1 and 2, and add them to get 3. And it goes 0, 1, 1, 2, 3, 5, 8, 11, on outward. But the ratio between those 2 numbers, as you go out towards infinity, or if you took the limit of the Fibonacci sequence, is the golden ratio, which the Greeks found to be aesthetically pleasing. It shows up a lot in nature. It's the conch shell. Have you ever seen the picture of that little arc as it circles inward? The ratios there are all the Fibonacci, or sorry, the golden ratio, which the Fibonacci sequence will approximate. So random little math trivia inside our functions here. But this is just a really great example of why functions are awesome, because you isolate out everything that can be isolated out into its own little function. So you have these distinct blocks of, you know, this, and you can tell these do exactly one thing, and then you just call them where you need to. Let's see. Did that work this time? Yes, okay. What other cool code can I go find for you? Do code. Let's see if there's anything in Python. We looked at Python a little bit earlier. Let's see if we can jump back in there. On cool functions. Actually, here's I can bring this up now. Here's what I'm of the opinion that something that should have a lot more functions and doesn't, and you can see why it starts to get a little confusing. Give me 1 second to pull this up. All right, here we go. You're back. I always have to check, because otherwise I don't know if you can see me. Okay, so down here in this parse message function, if you can see through the swimming amount of comments, which is a little hard, I'll be honest, you'll notice that there are these if blocks of if command 0 equals whatever, do stuff, and if do stuff, if do stuff. And you've seen this file before. I brought it up in the what you can do with stuff. I talk about how awesome it is. It is awesome, but you could isolate all of this out, this over here, into a library, just like you saw on the calculator, where I have all the operations defined in their own spot, and then we call them over here. You can see how much cleaner that is of just, you know, down here of all the different things you do. And then the logic is kind of put off in the library, so you can go look at it if you need to, but the flow and kind of the feel of it isn't interrupted. Whereas over here, over here, you scroll through this massive function, and you can see all the different stuff all together, but it's mucked up inside these if blocks. And this one's pretty simple because it's just if command, but if it was more complicated, if you actually needed branching for the interpretation of commands, figuring out what went where would get really complicated, just because this looks like alphabet soup compared to this and this. This is just, it's like there's so much more to look at that it just gets more confusing. So I think they should take all this and stick that in a function, and then just call the function right here. And that way, if you want to modify that function, you just go modify whatever file it's in, and it kind of separates things out. And they tried to do this over here, because this is the actual execution file for the bot. Notice LPMC bot. Once again, plug, learn programming, mentoring community. Go check it out. We have a lot of fun. We hang out, write cool code. Come join us. But you'll notice they tried to do this over here. Of break, like this is real simple. Of, you know, write log header, open log file. Yay, good functions. Yay. But send message, parse message. You'll see all that works out well. But when you go over here into their library, it's they need to have separated it out further, because does this name accurately describe what this does? Parse message. To parse means to separate out into distinct blocks. So in that sense, maybe. But it says we're going to separate out and interpret this message. Okay, but that doesn't say, and then we're going to do something with it. And like, you should have a naming structure that matches that. In this case, you should just say, okay, well, I've parsed it out into, I need to call this function. And then that function does its one thing of executing whatever you wanted that command to be. But it doesn't help you separate out the logic very well. So this is an example of how I think functions can be used more. Let's see, are there any major concepts I'm missing on functions that don't include object-oriented? Because starting tomorrow, we're going to start looking at object-oriented programming in classes, and that's a huge topic. I'm probably going to devote 3 lectures to it, and we still won't cover all of it. But you get more fun functional stuff when you can assign functions to objects, which you'll notice in the libraries when I mention it, and stuff like that. You'll notice, oh, I'm calling those functions. I try to avoid really explaining that because I wanted to explain it within its own distinct lecture, because it grows too big. You'll get lost in. This is a bad comment, by the way. Bad comments. You should have consistent commenting, either one or the other, but not both. I just noticed that while I was talking. So, yeah, that's functions. That's one good example, one bad example. I kind of already gave you kind of what you do with them. This was just kind of a follow-up. And I've now been talking for 45 minutes. Pretty much solid, and have kind of drained myself. I probably shouldn't try to record 2 lectures on the same day again, but I just really needed to get that second one back to you because it just refused to cooperate with YouTube. So I'm going to cut this one short at, whatever we're at, 17 minutes, looks like. So I will see you guys tomorrow. We'll start it on classes, and that should be a cool topic, and then yeah, I really need to be quiet. I'll see you guys.